Okay, 7.4 is over trig equations, or how to solve equations involving trig functions. And so we're going to look at a couple different approaches for solving equations. One of them is, of course, the graphical approach, where if I graph any two things, right, and I look at the intersection of these two functions regarding a certain interval, particularly intervals for periodic functions, because there's going to be a whole bunch of intersections if you're not careful. So example, this is the natural log of 2x, and this is the cosine function. And so if I were to put these in a graphing calculator, I would note that I have 1, 2, 3 intersections. Now let's say I only want from 0 to 2 pi. Well, in that case, I would only keep this one and this one, because this one lies outside of my 2 pi on my graph. Okay. Analytically, that's where things get hairy. So we're going to spend most of our time on this video really analyzing how do I deal with analytical problems regarding cosine, sine, cotangent, secant, blah, 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 blah. So what we're going to do is we're going to do our best to make our bases the same, or make them into something that I can put together, because these are additive. If this were multiplicative, we can do a little bit of a different thing, but we'll come back to those. Okay. So cosine can be written as 1 over secant. You could maybe use that. That might be helpful. Cotangent can be written as cosine over sine. Now, that's maybe helpful because there's a cosine and here's a cosine. So, all right, I'm going to write cotangent as cosine of x over sine of x. All right. Now I have something that looks a little bit more familiar. Kind of looks like I've got 3 maybe times 2 plus 2 over 4. So maybe think of that sign as a need to find a common denominator. Well, like anything else, I can multiply by 1. So there's my 1 right there. 3 cosine x sine x over sine x. Okay. Now I can start putting things together. So 3 cosine x times sine x plus cosine x. 3, I'm just going to rewrite that real quick. Cosine x sine x plus cosine x. And that will all be over sine. Now when you look at this, you should see, if you can see anything because it's so blurry, that cosine x lives here and cosine x lives here. So I can factor that term out, and I would have cosine x times 3 sine x plus 1. All right. Now, that is something I can solve. I'm going to multiply both sides by sine x. It's going to go to 0. And then I'm left with sort of an idea where I have something like, we'll say a times b equals 0, where this represents the quantity a and this represents the quantity b. So if I have two things that multiply together to make 0, then that means that one or the other or both are 0. So cosine of x equals 0, and 3 sine x plus 1 equals 0. Okay. Well, where does the cosine of x equal 0? Think about the unit circle here. Here's 1, 0, and our x value is our cosine. So when I go around, I'm going to see there it's 0, and there it's 0. So this is pi over 2 and 3 pi over 2. Now let's say that it just wants us to solve on the interval 0 to 2 pi. But beware, it may not. So we may have to do some kind of tricky thing there, and we can look at how we can write these a little bit more in terms of if I needed to go forever and ever and ever around that unit circle. Sine x equals negative 1/3. Well, I don't know what the sine, what the value of x would be. That if I took the sine of it, I would get negative 1/3. But I can imagine a couple of things. First of all, I can imagine that if the sine of x, which is y, is negative 1/3, then my answer had better live down here. Okay? The other thing I know is that I can go to my calculator and calculate out that value. So what I would put in my calculator is the inverse sine or arc sine of negative 1/3. Make sure my calculator's in radians because I just set my other answer in radians. Plus, if my question is given to find the answer on the interval 0 to 2 pi, you can infer that we're talking about radians. And then I would get x equals, and I'm going to guess a couple of different values. I'm not sure what those are. You can figure those out. This, comma, this. I want to look at some that are a little bit more confusing, or just some couple examples that might be helpful. I'm going to go ahead and X out of this presenter and close it up and open it up one more time in the hope that maybe that'll clarify the picture. So we're going to do that one time here. Let's see if that makes a difference in terms of our visual. Okay, let's do this one. The cosine of x minus pi over 3 equals negative 1/2. I'm sorry, let's make it positive 1/2. And let's say it's not just this, but gosh, it's this squared. So cosine squared of that. So sometimes this notation kind of tends to throw people off a little bit because it looks like only this part's squared, but really this notation is indicative of this. So this whole thing is squared. Okay, so those are the same thing. Equals 1/2. Now how do I undo a square? Square root. Cosine of x minus pi over 3. It's just an x, it looks like an xi. Equals plus or minus the square root of 1/2. Ew, that's kind of a very friendly number. So let's rationalize it and see if it comes out to be something that we like. All right, well, the square root of 1 is 1. Square root of 2 is just square root of 2. Well, I can't leave it like that. I'm not supposed to put irrational numbers in the denominator. So you're going to get 2 down here and root 2 here. Oh, hey, this is on my unit circle. Yay! So I've got my unit circle, and I know that I have outputs of root 2 over 2 here, 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 and here. Some of them are positive, some of them are negative, but on those intervals that would be my 45th degree or my pi over 2 degree, sorry, couldn't see that. On those intervals, I'm going to have some root 2's over 2. So I'm going to be aware of that. So the cosine of x minus pi over 3 equals either positive root 2 over 2 or cosine of x minus pi over 3 equals negative root 2 over 2. All right. How do I undo a cosine? Well, I use my inverse function. So x minus pi over 3 equals the cosine of root 2 over 2. So I need cosine, which is x. And I want to know, where is x positive? X is positive on this side of my graph. So I must be looking here at, there's pi over 2, pi over 4, and here is 1 pi over 4 back from 2 pi, so 7 pi over 4. Uh-oh, I've got more equations. So it equals this, or this. Now we don't write things that way mathematically, so we're going to break it up one more time into two equations. So I'm going to have x minus pi over 3 equals 7 pi over 4, or x minus pi over 3 equals positive pi over 4. So 7 pi over 4 or pi over 4. I'm going to add my pi over 3, and I'm going to have pi over 3 plus 7 pi over 4, or pi over 3 plus pi over 4. So that's just for this part, for the positive one. So what I want you to do is go through and complete the negative side. We're going to do the same thing. We're going to look at our unit circle, find those values, solve them out, see how many pieces I get. Now technically I should be making a common denominator and adding to come up with a final value here. So I'm going to expect that you do that in your copy.
Is that a light?
No, it's a camera.
Oh, were you just recording something and I totally ruined it?